Hello everyone, welcome back. In this video, we are looking into using logistic regression to classify handwritten 0 and 1 digit. We are using MNIST dataset for the training and testing data. The dataset is in GZ format. We can use Python gzip to load the training and testing data. We then extract the data containing digits 1 and 0 and random shuffle the data. Before training a machine learning model, we also normalize the training and testing data. This is because the gradient descent-based algorithm can converge faster when the features are on a similar scale. We also normalize the testing dataset based on the parameter found on the training dataset. This is because the goal of normalization is to make sure that the features are on a similar scale so that a machine learning model can learn the important patterns in the data. If the testing data is not normalized with the same parameter as the training data, the model may not perform well on the testing data, as the features may be on a different scale. Now let's visualize the data and see whether the data is what we want. Next, we are implementing the loss function and its gradient. For the binary classification problem, we can think it as drawing the sample from a data pool containing only two choices, 0 and 1, and assume their probability never change after each draw. For example, when we see handwritten 1, it means we draw the digit 1 from the data pool. Its probability is defined by sigmoid function. Theta is the linear coefficient of x, and x is the theta attribute. Theta will be optimized during machine learning process. Since there are only two choices in the data pool, the probability of getting 0 will be 1 minus h if the probability of getting 1 is h. The condensed form of this probability can be written like this. For m sample points, it means we draw m times from the data pool, so the likelihood of seeing all these m samples is multiplying the probability of each draw together. The log of the likelihood is our loss function, because it's faster to calculate it by the computer, and its gradient is easy to derive. I also want to point one thing here. When using regularization term, the theta 0 is not regularized because it's an interception term for all data points, not emphasized on any individual term. We are ready for training the model. First, initialize the theta to normal distribution random number. Second, train the logistic regression using Python minimize function with TNC algorithm. The truncated Newton algorithm is more efficient for the large-scale data because it does not require the computation and the storage of the Hessian matrix. Last, we calculate the classification accuracy with this training model for the training and testing dataset. Okay, that's all for today. Thank you for watching. See you next episode.